This is a short video to describe how I go about computing percent positive and negative sentiment from using a group by function. We've talked about other ways to do it using an ANOVA or just using a classifier, those kinds of approaches. But in this case, we want to use the group by function, which is a very nice way to not only identify the effectiveness of individual terms, but as a way to try to reduce the number of terms down to a smaller value, smaller number of terms. This is the same standard process we've been doing all along. I'm using the 2000 corpus, 2000 document corpus, so things are a little slower. And if you haven't increased your KNIME heap space to probably at least 1.5 gigabytes or 2 gigabytes of RAM, you should probably do that before you try to cram through the 2000 document corpus. We're doing the usual parse speech tagging, bag words creator, and then a bunch of the filters. And in this meta node, this is where I'm doing the positive and negative sentiment. So the first thing I'm doing is converting the category to class. And the category label, I'm going to back up here, was defined when we're loading up the data. Here's the document category positive, and on the other side, the document category is negative. These are this is metadata assigned to the documents, and when I do a category to class, use this node, it exposes that value and dumps it into a column. So now I'll have a column which indicates the class label value. This next term, category to number, converts those categories to a number, either positive or negative. It just goes through sequentially. In the first label, it finds the data assigns the number 0. The next label assigns 1. So negatives are assigned 1 because positives occurred first in the data. So positives are coded as 0, negatives as 1. But by coding it as a number rather than a text string, I can operate on it using the group by function. So the first group by here is it's grouping by term and document, and which should be the case already. We should have exactly one term per document, but just to make sure that was the case, I did this first. So this we'll have one term per document at this stage. Then the second group by, I'm grouping by term, and I'm going to count how many, here we look here, I'm going to count how many documents I have in the term, how many times that a term applies. So that's literally just a document count. And the second label is the document class. I'm summing it up. So for negative sentiment, this is just counting how many negative sentiment occurrences there are in the corpus of documents. So after I run through all of this, and after I rename these columns to the count from to total hits and the sum to num negative, you'll just see how many negative and positive sentiment values there are per term. And I can sort this descending to find out which term has the most number of negative sentiment hits, and that is film. Film occurs in 1,743 documents, and of those, 850 are negative. Movie is the second most frequent, etc., etc. And you can see the first one that really is a sentiment is bad, occurring in 475 documents as negative sentiment. So once we do that, then it's just simply a matter of using the math formula, which is an add-on. It's in the miscellaneous functions. It's right here, math formula. If you don't have this in your list of miscellaneous nodes, then make sure you go to the KNIME repository and add the math formula as one of the extensions to add in. Once you do that, then you'll see the math formula, and inside here we're just doing a very simple computation. We're taking the total number of hits, which is the number of documents that a term was found in, minus the number of negatives. So this total hits minus num negative is the number of positives, because remember we're counting negatives in this case. So it's the number of positives divided by the number of documents. So this is the fraction of positive documents, and I multiplied that by 100 to get a percentage. And the next one is the negatives, so it's the number of negatives divided by the total hits, which is the total number of documents that the term was found in, and that's the number of negatives. So the nice thing about this is at this point now we get our percentages and we can get some number which is interesting and easy to interpret, a lot easier than some of the other metrics like F-tests and those kinds of measures. And you can sort here. I'm sorting by percent negative, and we can see a bunch of that 100%. But some of these have very small counts. 5, 4, 3 counts. So, for example, Skimpy and Snails and Sphere are only occurring 5 times. They're all negative, but it's only 5 times. So typically when I'm assessing these, I'll make sure there's a minimum of a number of hits, number of documents, and in this case I just said 41. If it's less than 40 or 41, I'm tossing it out. And once we do that, and if I look at the filtered results after filtering those out, now we just have those that actually occurred a significant number of times. And we can see the top percentage in our list is wasted, followed by boring, inept, a bunch of things which are clearly associated with negative sentiment. So once again, to get that, I use the row filter node, and in the row filter node, I'm excluding rows based upon the value of total hits between 0 and 41. I could have said include from 41 to 2000, and that would have worked just as well. So that's the idea here. I'll describe what we do with the n-grams in a separate video, though it's going to be essentially the same as this process. The nice thing about this group by, if I go back here, is it's very simple. It doesn't take a lot of extra computation, and it's very transparent what's going on computing these positives and negatives. And at that, hopefully that will explain exactly what I was doing and why I was doing it. I'll create a separate video for the n-grams, and we can look at that at a later time.